even and odd functions, the basics. So if you say f and you plug in negative x, okay, we're going to evaluate the function with negative x instead of just x, and you end up with f of x, which was the original function, then the function is considered even. Now, that doesn't mean you have to do that. I'm just saying if you plug in negative x and it equals what you started with, well, then you have an even function, okay? So even functions are symmetric with respect to the y-axis. So it's like a mirror image on each side. Like think about a parabola y equals x squared. Okay, it looks like this, right? It comes down and goes back up. It's it's the same thing over here, a mirror image over here, right? So it's called an even function, okay? Even function. You end up with the original function. Again, you started with f of x, you plug in negative x, you end up with f of x again. It's the same thing. So if f of negative x equals negative f of x, notice what happens. You plug in negative x in the argument, and you end up with the opposite of the function, which basically means what? All the signs change. Then that's an odd function, okay? So odd functions are symmetric with respect to the origin. So what that means is if you have something over here like this here, this point here, you go this far and then go this far on the other side of the origin, boom, you're back on the graph. You go here, and then here, you're back on the graph, okay? So it's just symmetric with respect to the origin, all right? You end up with all the signs changed from the original function, okay? So with one of them, you end up with the original function. The other one, all the signs are changed. It doesn't have to be either one of those. So a function is neither even nor odd if it does not meet one of the conditions above. So it either is the function, it's even, it's every sign changed, it's odd, or it's neither even nor odd. All right. So determine whether the function is even, odd, or neither. So I got a few pages of these, and we'll just do a couple on each page and see what happens. So here, how do I determine that? I plug in negative x, right? So then f of negative x equals 2 times negative x cubed. So that's going to be 2, and the only proper way to do this is to put this in parentheses. If you did this, there's 1,000 things wrong with that. Even if you put a dot there, that's still wrong. So you got to put it in parentheses because you're cubing the negative and the x, okay? So this is going to be negative x cubed, right? Because a negative times a negative times a negative is negative, and x times x is x cubed. And so then 2 times negative x cubed is negative 2x cubed. And if you want to, you can say, hey, guess what? This is negative 2x cubed. This is simplified, y'all. I'm just going through and saying, okay, that's that. So that's going to be negative f of x, right? Because f of x was 2x cubed. So I can take f of x and plug in for that. That's all I did there. Okay, that's why I did the whole parentheses thing. That's negative f of x. You can see that without it probably. So f of negative x equaled negative f of x. So this is what? That's an odd function. That's an odd function. Anytime that happens, it's odd. So what about g of x equals 3x squared minus 5? Well, g of negative x is how we check it. If somebody asks you to check even or odd functions, you just plug in negative x and see what happens. If you get the function you started with as even, all the signs change as odd. If it's some other variation, then it's neither. Okay? So here, this is going to be 3 and then negative x. Let me fix that. That looks slanted. Negative x squared minus 5. Again, this is 3 and this is times what? X squared minus 5, and guess what? That is the same thing as that, right? So we said this equals g of x. So bring this side down. G of negative x equals g of x. That is exactly what an even function is, okay? So we have an odd one and an even one on this page, okay? An odd one and an even one. Because again, we did g of negative x, and we ended up with our function right here, right? This was our original function we started with. All right? So let's look at some more. Capital F of x equals x squared over x cubed plus 1. So capital F of negative x is how we always check it. Plug in negative x. We get negative x squared negative x cubed plus 1. So that's going to be positive x squared over negative x cubed plus 1. So it's obviously not my original function, right? This is the same, but this term is not the same. So, and if I go with all the signs changed, actually, with a fraction, you don't want both the signs in the numerator and denominator both changed. So what I'm going to do is I'm going to factor a negative out front and see if I got negative f of x, because it's obviously not my original function f of x. Well, it doesn't appear to be right now anyway, but maybe if I factor a negative out, it will be. So this is x squared, take a negative out, that's going to be x cubed minus 1, right? If I bring a negative out, that changes all the signs inside there. So then I'm going to bring this negative out front and say x squared over x to the third minus 1, okay? If the top or the bottom of a fraction, the numerator and denominator is negative, you can bring it out front if you have it factored. That's what I have here. Is this my original equation? Or expression of, no, it's not. So guess what? This is neither even nor odd. Okay? That ain't either one of them. So h of x, capital H, is the square root of 4x squared minus 7. So we check it how? H of negative x. That's the square root of 4 times negative x squared minus 7. So that's going to be square root of 4x squared minus 7. And that's the same thing, isn't it? So this equals capital H of x. And we bring this side down, h of negative x, capital H of negative x. So that means this thing is even. That means that thing is even. Right? You started with h of negative x, plug it in, negative x, you simplify it, and you end up with h of x, the original function. All right, little h of x, cube root of 4x minus 1. So little h of, what do we check it with? Negative x. So cube root of 4 times negative x minus 1. So this is going to be the cube root of negative 4x minus 1. If I try to bring a negative outside of that, that's 4x plus 1. And that's not, no, that's not the original function. It's not a negative out front. So that's neither. That one is neither. All right. And then finally, capital G of x. So we have G, capital G of x. Oops, we don't want G of x. We want to test it with what or check it with what? Negative x in there, right? So 2 times negative x cubed over negative x squared minus 10. So this is going to be 2 times negative x cubed over x squared minus 10, right? Because negative x times negative x is positive x squared. So this is going to be negative 2x cubed over x squared minus 10. And again, if I have a negative in the numerator or denominator and it's factored, this is times everything here, right? If I want to put that in there, I can, right? So I'm going to say this is negative and then 2x to the third times x squared minus 10. And guess what this right here is? That's my original function, right? So this is equal to negative f of x. So, I'm sorry, not f. Not f. Negative what? Capital G. Capital G. So capital G of x equals negative G of x. I'm sorry, I did it wrong again. G of negative x. We're bringing this down, right? I'm just on fire right now, right? So G, capital G of negative x equals negative capital G of x. So that would be an odd function. An odd function. So I hope this helps you with even and odd functions.